Welcome to lecture number 17. Last lecture we started discussing about different kinds of statistical models used in machine learning, and we will carry forward that. And I remember I started discussing on regression, which is the very simple model for any machine learning approaches, but regression has different kinds of variations. So, we will discuss today first that, then we will talk about something new, a new technique called classification. So, first you have to keep in mind the very basic things about machine learning. We are going to develop a computer program, right, and which can learn from its experience, and experience is nothing but data, and this experience is learned with respect to some task, class of task. Obviously, the moment you talk about task, you have to talk about performance parameter. So, a program which learns from the experience or data with respect to certain class of task and performance, this can be used to do more task with a better performance, right. That is what is the machine learning is. And experience is data, and each record is basically gives us a description of instance or sample. It can be called also instance also. Many of the books they use the word instance. And so, components that reflects the characteristics of this any problem is called features. So, therefore, basically idea is to find a model which can map the input with the output, and how best we can model it. That is the basic purpose of machine learning. And as I told you, machine learning is uses structured data. That means data needs to be pre-processed, and deep learning on the other hand doesn't require structured data. It can use unstructured data like in the form of text and images. So, we will talk about deep learning little later, because first you should know how to handle structured data, and then we can learn how to handle the unstructured data, that information from text or images, how it can be done. Okay, so ML process actually can automatically learn from the existing data, but nonetheless you require certain kind of a human intervention in the process. And as I told you that first thing you require is in machine learning is basically data collections or data generations, and data can be available from literature, you can get it from experiments, you can get it also from simulations, computer simulations, or you can generate data using different kinds of techniques. We will give you examples, or the TAs assigned to which will give you some live sessions in they talk about how we can generate data. And this is very important in material science, because in material science there are fields in which very less number of experiments have been done and available data are small. So, therefore, what you need to do is to generate data, and in generation of data we need to use certain kind of structural models or functional models and do that. We will obviously have discussions on this in terms of live sessions when you will give examples. But the next step, which is very important, is data engineering. That is why the data are pre-processed. I am not talking about that aspect right now, because pre-processing of data will be important when you know how to develop a model. So, I am skipping that particular part for the sake of interest of the course, but we will come back and discuss about data engineering in a very nice manner. And then followed by will be model, model training and model validations. So, training and what is called testing in the literature, and finally, you have a deployment, right, that is what it is called. So, training is what? Training is nothing but iterate something till you find the best model. You have data with you, you iterate to find a best model, and we are discussing about different statistical models, how to fit it, right. So, in that case we have to get some idea about mean, standard deviation and other aspects, and then you can use supervised or unsupervised learned models to develop a training model. After the training is done, you have to test, right, whether your model is working properly or not. So, that means you should test for prediction, whether the model can predict the output based on certain different value of input, and that is what is called test. and we have to use some amount of data to test the model. So, whenever you have a large amount of data, we divide the data into two parts, training data and test data. And training data is obviously the bulk, 60 to 80% data are used for training, and then rest 20% to 40% data are used for about testing. And there also again we test error, other things. We will discuss also those aspects much later. So, that is the step 3 and step 4, and we are discussing about these two steps first. We will go back to step 2 later, how to engineer the data. And learning, as I told, can be two types, supervised or unsupervised learning. In case of supervised learning, we develop a predictive model based on both input and output data, that is supervised learning. And there are two parts of supervised learning which are very important. There are many parts, but these two are important. One is regression, other is classification. We are going to discuss about these two techniques today itself in the class. And then you have something called unsupervised learning, in which you do not have the both input and output data, rather you have only input data. So, there you can actually group or interpret data based on only input, right. You can cluster the data, or you can do many other things. Obviously, clustering is one of the easiest thing which can come to the anybody's mind, right. So, these two are the major aspects of the types of machine learning. Supervised learning is used for alloy designing, unsupervised learning also can be used for very other kinds of things. It can be also used for complex alloy design also. So, in supervision you have a training data like observations, measurements or simulation data, and they will be accompanied by the output or levels, right. I have given you example in the last class for the time temperature data. So, you have levels and the input data, and then you can develop a model using supervised learning, and then new data can be tested. In unsupervised learning, okay, real example of the supervised learning is regression and classification. Unsupervised learning, basically you have class levels of training data are unknown. That means what? Then we have input, output levels are not known, and then you have a given set of measurements. So, idea is to establish existence of classes or clusters in the data. Remember, when you talk about existence of classes, we are not talking about classification. Classification is different, okay. But clusters are like features or the data which are similar type of features or similar type of importance in terms of the model. So, there are two groups of problems which we talk about: supervised learning, classification and regression, and that is what we are discussing. Let us talk about regression first. It predicts continuous values, right. What is regression? We talk about it is nothing but a statistical analysis tool that establishes a quantitative relationship between or among the variables, right. So, it is commonly used to find a relationship between a dependent variable or one and more independent variables, and that is what is basically done, and it is very important aspects. So, it is basically a statistical model that utilizes one quantitative independent variable x to predict quantitative dependent variable. By the way, it cannot be only one quantitative variable, it can be more than one quantitative variable also, and idea is to find out the quantitative dependent variables like that. Okay. So, we talked about it in the last lecture, and let us say that you have only certain input data with n samples, okay. Like I will go back to the board and discuss. So, that is much better. So, in regression we have what? We have basically data sets with both, let us say, n sample data sets. I also discussed in the last class, let me reiterate again, and your variables are xi, correct. I can go to 1 to n, right, and your levels are ti. They are actually also I can go from 1 to n. These are called levels or output values corresponding to xi, and this is called your variables, independent variable. It is better to write independent variable. Okay, so we know the correlation between these two, and this xi and ti are part of the sample space, right, that is the R. So, our idea is to find or basically find out quantitative relationship between xi and ti, right, that is what it is. So, quantitative relationship can be obviously linear and non-linear. First regression analysis is linear regression, which is the easiest one. Linear regression is the easiest thing to understand, right, because quantitative relationship between x and t will be linear. So, how we can define that, because remember these are data, these are not functions, right. And best way of writing a linear relationship is very simple. Let us say my yi, or let us write ti. Ti is your output, is given by W0 plus W1 x 1, right, W2 x2, W3 x3, goes up to Wn xn. This x1, x2, x3 to xn are actually variables, independent variables, right. You can see xi, it can go to 1 to n, and ti is basically what? It is the value of the level or output. So, this is very simple model of that, but you know this has to be added with some error, right, because whatever you do, this is a data which you are modeling, you will have to accommodate a certain amount of error, and this is what is called epsilon I. So, now in the matrix form we can write down T equal to capital X W plus epsilon. Okay. So, how do you do that? Let us write that. So, T is basically like this, T1, T2 dot Tn, and then x is like this. So, let us write down the x 1 x yes x 1 I to x p I, right, yes, that is correct. Or many times people write this x 1 1 and x p 1 p, better write to 1 p. This is x 1 varying from 1 to p, then x 2 1, x 2 2, this you can write also x 1 2 to x 2 p, then it goes on 1 x n 1, x n 2, x n 2, it goes to x n p. That is my x, and what is my w? W is again W 1, W 2 to W n. So, you can multiply this matrix 1 into W 1, okay. Then x 1 1 to W 2, you can see that x 1 1 to W 2, x 1 into W 3, okay. You can do that, or it's better to actually write down this way T I minus W 0, it is a constant, equal to W 1 x 1, W 2 x 2, W 3 x 3, then it has become much better, W n x n plus epsilon I. This is has to be added with what? Added with epsilon. Epsilon will also be in the matrix format, right. So, you can see that is equal to matrix format. So, it will be also epsilon 1, epsilon 2 to epsilon n. This is basically what is used fundamentally in the programming, the computer programming, this matrix format of analysis used. This is called linear regression. We can clearly see we are basically adding, these are weighted factors W 1, W 2, W 3 weighted factors. Now, because we do not know which variable is making strong impact on the output, we have no idea initially. So, we can actually put different weights on each of these variables and see which one is fitting good correct. That is what we can do. Hope this is understandable, because this is very simple, there is nothing much to be done. So, this is what is my matrix form. Okay, that is something which you should be able to do that. And in this case also, in this slide, again I wrote the same thing. You can see that y, okay, y is your dependent variable, beta 0 is your first, same as a w 0 there, then beta 1, beta 2 to beta p by beta n, and then you have error term. That is what the linear regression is done. And basically it is better to write in the matrix form, as you know, x beta plus epsilon. This is your matrix form. And in computer programming matrix forms are much easy to understand. So, now you can also have multiple regression, that is what we have done. Okay, you can also have multiple regression, that is what the equation is. It basically tells you different kinds of variable x 1 to x p, how this can predict the quantitative variables, correct. So, have at least 1 or 2 variables required for this. This is again shown here, same thing, basically nothing different much, you can see that is exactly again shown there. So, now we talk about, before we go to nonlinear models, let us talk about little bit about what kind of errors, how do you estimate the errors, how do you optimize this kind of regression, let us talk about it. So, one can have only single variable x, one can have more than one variable like x, y, z also. In that case, it will be one series of x, another series of y, and then third series of z, right. So, w 1 x 1, w 2 x 2, w 3 x 3 goes to w p, w n x n plus again w 1 prime y 1, w 2 prime y 2 plus goes to up to n, that like also possible, right. But that will add into complexities. But as you know, machine learning is a computer based program. So, adding complexity is always better, because a output can depend on more than one variables, correct. Then what do you do, how do you model it? Basically it is talking about more than 2 variables, 3 variables, the space is changing from linear to, space is changing from 1D to 2D to 3D. Okay, let us come back to the discussion what we are doing, how do you do the optimization, how do you do the error analysis, okay, and focus your attention to what I am saying nicely. So, optimization, okay, what do you do optimization of that? So, very simple, we have to minimize the loss or minimize the error. People call it a loss or cost. In the economics people call it cost, statistics people call it loss, but it is basically error. Engineering error is very common term. And what is error? It is nothing but difference between what? Between the practical value, between the predicted value and the true value. Once you test the model, this is what will be your difference between the predicted and the true value, right. So, this has to be minimized, that is the idea. So, what you do is basically use quadratic loss function to do that. And what is this quadratic loss function? Very simple. So, quadratic loss function is written like this. Let us say this is a quadratic loss function, lambda x is equal to c t minus x whole square, okay, where c is a constant. It can be taken 1 also, and if it is taken 1, it will be lambda x equal to t minus x whole square. This is nothing but what? Variance analysis, right. This is nothing but variance analysis or similar to variance analysis actually. In variance also you take the difference of that. So, what you can do is basically much better will be to take a summation T I x I whole square. correct. If you are taking each value and do that. So, that will tell you the error in each point, but normally you do not do that. What you do is basically take this equation in toto, right. That is what is we use. So, in the machine learning language, this is known as a JW. This is statistical language. Machine learning is known as a JW. JW you have to minimize. You have to minimize what? You have to minimize in terms of W, right? Because W is what is you are changing. You have to minimize in terms of the W. Let me write it clearly. So, minimization of W. Then what do you do? Very simple. Is take x in matrix format, right? X W minus y whole square. Correct? That is what you do. So, you can see this is x w and then y. So, if I take a minus of that, what do you have? You remain only epsilon. So, you are minimizing the error or epsilon basically, nothing else. So, there are many ways one can do that, okay. But this is the standard formula one can do, and this error has to be minimized. Remember, when you are doing the regression analysis, that is the basically idea of doing the regression. So, this is standard for everything, all the regression analysis, this is what is used. Now, one can use instead of quadratic, one can use other methods also, but those are not very effective. The quadratic loss function is more effective. This is also used in economics also as a quadratic cost function. So, I do not want to talk much beyond that, because this can lead to one extra lecture or so. So, let us go ahead with other regression things. So, we talked about linear, we talked about error. What are the other regression? There are many regression techniques available, I gave you in the last lecture. Obviously, one is polymeric, one is called nonlinear, or what is known as a polymeric or something, right. Polynomial, sorry, not polymeric, polynomial. Oh, this has to be written here only, right. Why? Poly or nonlinear regression, and that is very simple. Why it is very simple? Because we can write down the equation very simply, that now that you know the equation. So, for linear, what do you write? Y as a function of both x and w, this is for linear, right. Compare this with a nonlinear or polynomial, that is equal to w 0, w 1 x 1, w 2 x 2 going up to w n x n, right, where n goes to n can be anything. So, polynomial or nonlinear will be like this. It will be, so y x w is equal to w 0 plus j go from 1 to m minus 1 n minus 1, correct. So, w j phi j x, correct, where phi j is a nonlinear function. The top equation can also be written like that. But there phi j is a linear function. But there are different kinds of nonlinear functions possible. That is why we put a nonlinear aspects. Very clearly, that is what is the real aspects of discussion. Here you can see the nonlinear things can be, say, parabolic, hyperbolic, okay, all kinds of curvilinear models are available. We will go back to the board little later. First thing is nonlinear is a logarithmic, right. You can clearly see we have put a logarithmic function here, right. What is that we have placed here? we have placed a logarithmic function y equal to beta 1, here we are using beta by the way, beta 0 beta 1 log x 1 plus beta 2 log x 2 plus error. So, based on the value of beta 1, the functions can look like positive slope or negative slopes, right. That is the simple logarithmic, because you do not know what kind of function will fit your data, right, in case of nonlinear. That is why you have to try with different kinds of things. So, log is one very important one, and then you can also have square root transformation. What you are doing is basically taking a square root of these values x 1 I plus or x 2 I, what you can add many more terms, and then based on the value of beta 1, here we are showing only the first coefficient, beta 1 corresponds to W 1 in the board. Okay. So, there are some mismatch between the variables which are used. So, beta 1 values can be negative or positive, based on that curve will look like this. Okay. Then you can also have reciprocal transformation possible. You take 1 by the variables, 1 by x 1 I or 1 by x 2 I, you can also take that, right. And this kind of function will have asymptote values. You can clearly see that there is asymptote values when you go for beta less than equal to 0, there is a asymptotic value upper value, and when a beta less greater than equal to 0, there will be asymptotic value going up to infinity. So, you should have some idea about this kind of behavior of these functions. Remember, you are talking about a very simple function, and you should have a good idea of how this simple function will behave. You can also have exponential transformations, right. You can see that e to the power beta to 0, then other things. Or you can also put e to the power exponential in the for the function also, like x I, x 1 I or x 2 I also, correct. That is also possible. So, there is a plus sign missing there, it is basically plus this one. So, these are the different kinds of nonlinear or say polynomial aspects can be written, but I will write down the fundamental equation of that, which is given in the book of artificial intelligence for machine learning, material science, in this book also. So, finally, it will be in terms of what is that called matrix form also. So, that is we have written. So, how it will look like? Very simple. So, y 1 y 2 goes up to y n, correct, is equal to this x will be 1 into, you can see that what will come x 1 x 1 square goes to x n square 1 x 2 square go to x this will be x 1 to the power n, x 2 because we are talking about nonlinear in terms of n, right. So, then it goes x 2 x 1 sorry x 2, this will be x n x m, let us write down, this is better, then it become n is preserved for this one, x n square goes up to x n to the power m, and then you have a error plus, right, sorry, w will be there, right, w is missing, multiplied by w, and w is will not going to have nonlinearity. So, w 1 w 2 w 3 goes to w n plus epsilon 1 epsilon 2 epsilon n. This is the matrix form of this polynomial regression. You can add, you can have any function. This is here it is showing only power, that is like a typical polynomial, but nonlinear ones can have exponential, can have logarithmic functions and many other functions possible. So, these are the two important things which you discuss. I will come back to the second part of the lecture, where we will talk about other kinds of regression methods like lasso or ridge regression methods. Okay, thank you. Soon we will come back to the next part of the lecture.